Okay, good morning, children. We are starting with a new chapter, a very important chapter, uh, named Thermodynamics. So, if we analyze this word, there are two words present. One is therm. Therm means heat, and dynamics. It means flow. Uh, heat flow. Okay. You know, when heat is made to flow. What is the importance of this chapter? When heat is made to flow in a proper manner, we can get work out of it. We can get energy out of it. That energy we can make use in our useful purposes. So that is a basic thing in this chapter. Now, before we study thermodynamics, we should be clear with some common terms that are involved in thermodynamics. The first thing that we have to do is system. Often in our discussion in thermodynamics, this term will be coming, system. Now, what is system? Suppose we are carrying out some experiment in the test tube. Suppose we have we have added water. And say we are going to study the property of water, suppose. So this water is our system. Suppose in another case, we have here say calcium carbonate, and we are adding into it dilute HCl. So the content of the test tube here, that is our system. So, what is system actually? System is a part of the universe. System is a part of the universe which is under observation. Now, there are three important types of system that we study. One is open system, closed system, and isolated system. Open system, closed system, and isolated system. Suppose we have water in this container, and we are trying to measure. Suppose this water is at 80 degrees Celsius, and we are doing some experiment. Say we are measuring its temperature with the help of a thermometer. So this will form an example of open system. Why? Because okay, before I discuss further on open system or this system, let me come across another term, that is surroundings. So first we have discussed system, second is surrounding. So what is surrounding? Other than the system, everything around us will be called as surroundings. Other than the system, everything around us is called the surroundings. Okay, so coming back, what is open system? We have water here at 80 degrees Celsius. we are trying to measure the temperature of water with the help of thermometer. This forms an example of open system. Why open system? Because this system will be able to exchanging energy with the surrounding. It can also exchange mass with the surrounding. If energy and mass both gets exchanged with the surrounding, then it is called open system. If this liquid is at 80 degrees Celsius, after some time its temperature will be less. Why its temperature is less? Because it has exchanged heat, it has transferred heat to the surroundings. Okay, now an example of closed system. Closed system is, say, if say we have some liquid say in a closed container. Suppose this is a closed container. This is a closed container and some liquid is there. Now this liquid or this system can exchange energy with the surrounding. It can exchange energy with the surrounding. Now, say heat energy can flow into it, heat energy can come out of it, but there cannot be transfer of mass between system and surrounding. There cannot be transfer of mass because it is closed. So mass transfer is not possible, but only energy transfer is possible. Then it is called closed system. And what is isolated system? Isolated system, suppose we consider an example, say thermos flask. Thermos flask. And say this thermos flask is a perfect thermos flask. Though we don't get in reality, suppose it is a perfect thermos flask. So in this thermos flask, what will happen is, if we keep here a warm liquid, if we keep here a warm liquid in a thermos flask, provided it is a perfect thermos flask, its temperature is going to remain same even after 10 days, 15 days. Amount of mass here will also remain same, whatever be the period of time that has taken place. So what I mean to say is that in case of this perfect thermos flask, there won't be any transfer of mass with the surrounding, there won't be any transfer of energy with the surrounding. Okay, then if there is no exchange of mass as well as energy between system and surrounding, then it is called isolated system. So we have discussed the system, we have discussed surrounding, okay, and after that what we will discuss is your state of system. State of system. Now suppose we have a system here. We have a system here, and say this system is under observation. This system is under experimentation. So in order to know about the system, we have to know so many things about the system. For example, we have to know its temperature, temperature. Say we have to know the volume of the system. We have to know, say, number of moles present here. We have to know pressure. Suppose it is a gaseous system. We have to know pressure of the system. So, like this, if we want to know the system, if we want to know the state of the system, that means we have to know, what is its temperature, what is its volume, what is its, how much number of moles is there, what is the pressure. So, if we know all these things, then only we can say that we know the state of the system. Just like, suppose for a teacher, if a teacher has to know, a teacher before teaching students, a teacher has to know about the students. A teacher has to know about the name of the student. A teacher has to know how good or how bad the student is in, say, a particular subject. What are the strengths of the students? What are the weaknesses of the students? The behavior of the students. So, as teacher has to know all these things before teaching a particular student. Similarly, when we have a system, when we are doing experiment, when a system is under observation, we have to know about the state of the system, and we can know the state of the system only if we know about its temperature, volume, pressure, and number of moles. And there are many more things that we will come across in this chapter. This all you know, but some more things which are very important which will come in this chapter is say the enthalpy, whose symbol is H. Okay, we have to know the enthalpy of the system. Then say entropy, whose symbol is S. We have to know the entropy of the system. So all these things we will know the definition. Then say Gibbs free energy, whose symbol is G. That we have to know. So when values assigned to these parameters are known to us, then we can say that we know the state of the system. And that is the reason why these parameters can be called as state variables. These parameters can be called as state variables. Okay. Now let me talk about next thing is state function and path function. State function and path function. Okay, suppose we have a system. We have a system, and say the value of enthalpy of the system is say H1. You don't know enthalpy, but suppose we know the enthalpy of the system, and the enthalpy of the system is H1. Okay, now suppose a process is carried out on the system, and suppose so if a process is carried out, the state of the system definitely is going to change, and suppose the value of enthalpy now of the system, since a process has been carried out, the value of the system is going to change, and now suppose the enthalpy value now it is H2. So this is state 1 of the system, this is state 2 of the system. So what is the change in the enthalpy value? Change in enthalpy value, which is, we can call it a delta H. So delta H will be H2 minus H1. So this is the change in enthalpy value. Now you see, there can be many ways, for changing the system from state 1 to state 2. There can be many ways, there can be many paths. Suppose this is one path A, this is say another path B, and pathway. If the system changes from this state to this state, say through path A, if the state of the system changes from state 1 to state 2, say through path B, even if we carry out the change in different paths, if the value of enthalpy change remains the same, or if the value of enthalpy change will be same irrespective of the path followed, then that is called your state function, and that parameter is a state function. Like enthalpy is a state function. So I'm telling once again, if a system goes from one state to another state, and if the change in property of the state of the system does not depend on the path followed, okay, then that function, that parameter is called state function. Enthalpy, you will see enthalpy is the state function, entropy is the state function, Gibbs free energy, in the state function. Now all parameters are not state function. I am telling you now a parameter which is a path function. Okay. Suppose we have a system here. And say heat of the system, say if it is say Q1, heat is say Q1, and some process is carried on the system, and the system comes to a new state. This is say state 1, this is say state 2, and it came to another state, and suppose the heat now is Q2. Now the heat change, it is say delta your Q, which is Q2 minus Q1. Its value will be different. The value of delta Q will be different for different path followed. And such a parameter will be called as your path function. Such a parameter will not be a state function. Now coming to this process that we have carried out. There are different types of thermodynamic process. There are different types of thermodynamic process. So I am writing here now 5 types of processes. Types of processes that we are changing state. One as we are going from one state to another state. That can be done by different types of processes. What are the different types of processes? Say first of all, say isothermal process. Isothermal process. Isothermal process means during the process, if temperature is kept constant, temperature is constant, so that delta T is 0, then that is called isothermal process. Then suppose during a process, pressure is kept constant. Pressure is kept constant, so that there is no change in pressure. Then that is called, isobaric process. Isobaric process, if pressure is constant. Likewise, there are processes where volume is kept constant. That is called isochoric process. There are processes where amount of heat or heat transfer is 0. There is no heat exchange between system and surrounding. So such a process where heat exchange is 0, that is called adiabatic process. Okay, now today we will be doing this much only. So in our next video I will be starting with a very important topic which is under this only types of process, that is reversible process and irreversible process. So children, a very important chapter, thermodynamics, some terms we were doing. There are some few more terms left that I will be covering in the next video. Till then, bye bye and have a good day.